The next lesson in Chapter 8 is 8.6, Solving Rational Equations. In this lesson, we'll look at solving rational equations and checking for a new type of extraneous solution. Solving rational equations with one fraction on each side means that you want to eliminate the denominator. And here's how we do it. The first thing we're going to do is factor, and then we're going to state restrictions. Now, if you have just one fraction on each side, step 3 is pretty straightforward, and that's what eliminates the denominator. We're just going to cross multiply. Once you cross multiply, the denominator goes away. And now it's just basic algebra. You want to solve for your x variable. That may require moving things over by adding and subtracting. It may require factoring and or quadratic formula. When we look for extraneous solutions here, we're looking for extraneous or solutions that are also in the restriction. If you solve for x and you say x can't, or x is 4, but in restriction you said x couldn't equal 4, then that's what makes it extraneous. Oops, and I meant restriction, not plural. So let's go ahead and fix that quick. There we go. So an extraneous solution is a solution that's also in the restriction. All right, let's try a couple of them out. The two examples we'll try, what is the solution to each rational equation? In example A, we have x plus 1 over x minus 3 equals 5. To start things off, I want to have a fraction on each side. I'm just going to simply place 5 over 1. I'm also going to recognize the importance of placing parentheses around anything that has that addition or subtraction. Step 1, factor the denominators. Notice all we have is x minus 3 in the first one and a 1 in the second one. Nothing needs to factor. Step 2, though, stating restrictions. Because of that x minus 3, we know that when we solve, x can't equal 3. That would make that fraction not possible. Step 3, cross multiply. When we cross multiply, I'm just going to take everything in the first kind of location and multiply it with everything in that bottom location, x plus 1 times 1. That's pretty easy. That'll just be 1. When we multiply in the other direction, though, this is what eliminates the parenthesis. We're going to take that coefficient of 5 times x minus 3. It doesn't eliminate the parenthesis. It eliminates the fraction. Sorry about that. All right, from here, we just want to solve for x. Let's first get rid of now those parentheses by multiplying. On the left, x plus 1 just stays x plus 1 times 1. On the right, 5 times x minus 5 times 3. And now it's a matter of just combining like terms. I'm going to subtract x to move it over to the right, and then add 15. And what this does is gets all my variables on one side and then all the constants on the other. 1 plus 15 is 16, and on the right, 5x minus 1x would be 4x. Divide both sides by 4, and x equals 4. Just to double check, notice that's not our restriction, so x equals 4 is our final answer. Now, one thing to recognize as we solve equations, the restriction is not part of the answer. So we only use the domain to check for extraneous solutions. That's different from, oops, I can probably write that in there. That's different from what we did in 8.4 and 8.5. So we only use the domain to check for extraneous solutions. It actually isn't part of our answer. We're trying to solve for the values that x can equal. It doesn't matter what they can't equal, as long as it doesn't create that extraneous solution. In our second example, we have 1 over 2x plus 5 equals x over 11x plus 8. Again, start off by factoring the denominators and also recognizing that, yeah, we should probably put parentheses around these. It doesn't look like anything factors out of 2x plus 5 or 11x plus 8, but I recognize in the domain that if we have 2x plus 5, x can't equal negative 5 halves. And if we have 11x plus 8, x can't equal negative 8 over 11. To solve each of those, just say they can't equal 0 and solve for x separately. Now there's no common factors, so we're just going to go right to that cross multiply step again. And this time we're going to end up with something that's quadratic. If we take 1 times 11x plus 8, we just get 11x plus 8. But when we cross multiply in that other direction, Notice we have an x on the outside and then 2x plus 5. That's going to require us to distribute that x in, and we get 2x squared plus 5x. Now it's not as easy to get all the x's on one side and everything else on the other. We do have to set the equation equal to 0. To do that, what I'm going to do is just move the 11x over and move 8 over, like so. That gives us 0 equals 2x squared minus 6x minus 8. I'm going to go ahead and factor out my 2. That's our common factor. And that gives us x cubed minus 3x. X cubed, wow, I have no idea where that came from. It stays x squared. There we go. Sorry about that, everybody. Minus 3x and then minus 4. Now what we can do here is just get rid of that 2. It doesn't impact our answer for x. So then up here, and this will make our factoring hopefully a little bit more manageable as long as we have the right exponent. Can you think of two numbers that multiply to get -4 and add to get -3? Hopefully you recognize pretty quickly that that would be x minus 4 and x plus 1. Now remember, we're trying to solve for x. If we set x minus 4 equal to 0, x equals positive 4. And that's not one of our restrictions, so just double check that. We're good to go there. And then x plus 1, if we set that equal to 0, x will equal -1. Also not a restriction. We have two unique solutions for this rational equation. If all we had to do was cross multiply, that wouldn't be too bad for a lesson. But we are going to have certain scenarios where there's multiple fractions on either side of the equation. When we see that, like the example 2 down below, what ends up happening is we have to follow some steps that we had from 8.5 day 2. So step 1, follow steps 1 through 5 from 8.5 day 2, where we factor, state restrictions on the domain, come up with the LCM, convert each fraction, and then simplify the numerators. Yeah, it's a lot. So step 1 here is actually steps 1 through 5 from 8.5 day 2. Then what we get to do, this is kind of fun, we get to cancel out all of the denominators. If we're trying to solve for the value of x that makes the fraction equivalent in these equations, we're trying to solve for the numerators only. So we just have to set them equal to each other. And we'll just solve for x like we did up above. That's not step 5, that's step 3. Instead of repeating a bunch of those steps, I just kind of condensed step 1, so I forgot to make that step 3. Sorry about that. And then we'll once again check for those extraneous solutions, those solutions that are also in the restriction. Here's what it looks like. What is the solution for 1 over x plus 5 minus 5? Wow, plus 1 over x minus 3 equals x squared over x squared minus 8x plus 15. I will get us through this, I promise. All right, step 1. We do need to factor the denominator, recognizing in that on the left-hand side, we've got x minus 5, I'm going to put that in a parenthesis, x minus 3, and then x squared minus 8x plus 15. That will factor into x minus 5 and x minus 3 as a product. All right, because of all those denominators, we're going to talk about the restrictions in our domain, recognizing that this just helps us determine what we know about our solutions. We know x can't equal positive 5 or positive 3. I'm not going to double underline those because I just want to verify at the very end whether or not we have the correct solutions to our system. All right, so now from here, instead of cross multiplying, we need to find the LCM. Take a look at all your denominators. I see an x minus 5 and an x plus 3. There are no coefficients out in front and there are no monomial terms. So the LCM is just going to be x minus 5 times x minus 3. The next step from 8.5 day 2 was convert each fraction. Taking a look at 1 over x minus 5. In that LCM, it still needs the x minus 3. If you multiply it on the bottom, we have to also multiply it on the top. And then it's plus x over x minus 3. And now we need the x minus 5. Like so. So this is very similar to what we did in 8.5 day 2. What's nice on this right-hand side is it already has the common denominator, x minus 5 and x minus 3, or the LCM. So we don't have to make any changes on that right-hand side. All right, so once you do that, let's go ahead and simplify those numerators. x plus 3, or excuse me, x minus 3 just stays x minus 3. We'll distribute the x in, x squared minus 5x. On the right, set it equal to x squared. And now the fun step, we can totally eliminate the denominators. We're not solving those when we solve equations. We're just solving what's in pink down below. To try to combine like terms, this gets even better. Notice we have quadratics, so if I want to move my x squared over, it actually just ends up canceling out. How awesome is that? And then that leaves us with x minus 5x, which would be, why did I not cross that one off? Sorry, there we go. Crosses off on both sides. And then that leaves us with x minus 5x, which is negative 4x minus 3 equals 0. I'm going to move 3 over. Almost out of space here. Negative 3. Wow. Oh, you guys, I don't even know what's happening to me right now. It's been a long day. All right, negative 4x equals 3. And we'll divide both sides by negative 4. Whew, there we go. We get x equals negative 3/4. Double check that. It's not in either of those restrictions. So x equals negative 3/4 is the solution to that rational equation. And we have two more. What are the solutions to the following equations? 5x over x minus 2 equals 7 plus 10 over x minus 2. Right away, I'm going to leave everything a fraction and put 7 over 1. And I'm also going to write those x minus 2's in parentheses. From here, notice there's nothing that factors out of x minus 2. Let's go ahead and find out what our restrictions then would be for our domain. If x minus 2 is in the denominator, that means x can't equal 2. Now for our LCM, this is actually going to be pretty easy to start us off. I see an x minus 2 in one location in one fraction and an x minus 2 in the other, and then that 1. Now the 1 as a least common multiple doesn't impact your LCM at all. That means our LCM is simply going to be x minus 2. So that should make this pretty easy to set up. In that fraction on the left, it already has the x minus 2. There's nothing more we need to do there. Over on the right, 7 has a 1 in the denominator. So let's change that up. Let's give it the LCM in the denominator and then also show that in the numerator. And then plus 10 over x minus 2. Nothing needs to change there. All right, let's clean up the numerators. We have 5x equals, I'll distribute the 7 in, 7x minus 14 plus 10. And that's all you do there. And then voila, the denominator eliminates. Just get rid of that altogether and solve what's left over. If we combine like terms for the equation in pink, I'm going to move 7x to the other side. And that gives us negative 2x equals negative 4. Now when we divide both sides by negative 2, we get x equals 2. But now that's a restriction. So that means even though x equals 2 solved what we had left over in part of this work, it actually doesn't fit with that restriction in the domain, and it would make that fraction in the original equation not possible. Because x equals 2 makes the rule extraneous, and we have no other options, that means there's no solution to that rational equation. Our last example, 2x plus 2 over x minus 1 equals 4 plus 6x over x plus 4. So we know we have to have at least one problem that's going to require a little bit more work. Now step 1, factor the denominator. We actually don't have to do anything with the 2x plus 2 on the top. I know usually we would take out that 2, but because we're trying to find the LCM anyway, we're just going to have to multiply it all back together. So I'm really only worried about my denominators, and I've got x minus 1 and x plus 4, and then I'm going to put 4 over 1. None of those denominators factor, but that does give us two unique restrictions in our domain. If x minus 1 can't equal 0, we know that that can't equal positive 1 for x, and then x plus 4 can't equal 0, we know that that can't equal negative 4. Okay, next step, let's determine that LCM. Again, the 1's not going to impact it at all, but we do have x minus 1 as one of our binomials times x plus 4. This one's going to get a little tricky. All right, so in that first fraction, I'm actually going to add a parenthesis around that 2x plus 2. I should have done that before. If we have 2x plus 2 all over x minus 1, it's still missing that x plus 4. So let's give it that LCM in the denominator, but then we also have to put that in the numerator. And then I'm going to move my fraction bar over because I think I'm going to need this space. Oops, I want that in a different color. Okay. And that second fraction, 4 over 1. Notice that one doesn't have either denominator, so I'm going to have to extend my fraction bar quite a bit. We need the x minus 1, and the x plus 4. Yeah, this one's going to be a little tougher. We'll get through it. And then plus, I have a 6x and the x plus 4, but this one needs the x minus 1. Okay. All right, so here's what I'm going to have you do. I want you to try this. Go ahead and FOIL on the left-hand side, FOIL on the right-hand side, then distribute the 4, and then distribute the 6x into that parenthesis. Once you think you've done all that work, press play, and that'll save us a little bit of time in the video. So FOIL the left side, FOIL and distribute the right side, and then distribute, and then press play, and we'll finish this problem. On the left-hand side, I ended up with 2x squared plus 10x plus 8, and on the right-hand side, 10x squared plus 6x minus 16. Feel free to take a look at that work. If you did not get those values, pause the video, and make sure to add that into your note packet. So unlike the last term where some of did our x squared term cancel out? No, we didn't have an x squared term. So not unlike the last term, what we have to do here is actually set it equal to 0. We still keep our quadratic terms. Noticing that 10x squared is the bigger x squared coefficient, I'm going to move everything over to the right. So we'll subtract 2x squared, subtract 10x, and finally subtract 8. Setting that equal to 0. On the right-hand side, we get 8x squared minus 4x minus 24. Recognizing that we could factor out of 4, that should be helpful. That would give us 2x squared minus x minus 6. Okay, so let's see what we have here. We can divide both sides by 4. And that would give us 0 equals 2x squared minus x minus 6. Now, we're going to have to factor this, so let's see if it's factorable. Hopefully that will work for us, which means we're going to have to do a times c, split to get b. 2 times negative 6 is negative 12. Negative 12 would break down into negative 4 times positive 3, so that splits that bx term. And then we'll drop down the 2x squared out in front and the minus 6 at the end. All right, put a parenthesis around the first 2 and second 2. We can take out a 2x and we get x minus 2. And then in that second parenthesis, we could take out a 3. Whoops, where'd my pen go? Hang on. Take out that 3, and then we get x minus 2 again. That means x minus 2 is one of our options, and then take the parts on the outside, and we get 2x plus 3. Oh boy. All right, now set them each equal to 0. Wow. We have x equals 2 and x equals negative 3/2. Go back up to the very top. Are either of those our restrictions? And that answer is no. Therefore, we get 2 solutions. That is 8.6.